Okay, this is a video on how to solve simultaneous equations in the Graphically method. That's by drawing a graph. So there's 3 different ways to solve simultaneous equations, and this video is just focusing on Graphically. So first step, we have these 2 equations. We have 3x minus 6 equals y, and 4y equals 3x plus 12. So our step 1 is to find the x-intercept, so the y-intercept. So to find the y-intercept, we make x equals 0. And that's just what I've got here. So we just substitute that in. So we have x here, we just replace it with 0. So we have 3 times 0 minus 6 equals y. And then we just tie that up. So 3 times 0 is 0. So I just write that as 0 minus 6 equals y. Then I can tie that up because 0 minus 6 is just negative 6. So we have negative 6 equals y. And then I like to write this just the other way around, just because I like to have my letter on the left side. So y equals negative 6, which tells us our y-intercept is negative 6. That's done for this one. We found our y-intercept. Now we do this equation over here. So again, we let x equals 0. We're finding our y-intercept. So we just replace the x here with a 0, which we can see has happened. Then we just tie that up. So 4y stays the same. 3 times 0 is 0. So we have 0 plus 12. Then 0 plus 12 is the same thing as just writing 12, because adding 0 to something doesn't do anything. Okay, and then we want to get y by itself. Well, it's getting the rate that is 4. They're being times together. So we write things next to each other in algebra, we're timesing them. So we have to do the opposite of timesing, which is dividing. So we divide both sides by 4. So we do one side, we have to do both. So 4y divided by 4 just leaves us with y. Then 12 divided by 4 leaves us with 3. So our y-intercept for this equation over here is 3. Now our step 2 is going to be to find the x-intercept. So to find the x-intercept, we let y equal 0. And we start with this equation over here. So replace the y with a 0. So we have 3x minus 6 equals 0. And we don't really need the brackets here, so we just write that like so. And then we want to get 3x by itself. So to do that, we need to move this negative 6. Because right now it's being subtracted, we need to add 6 to both sides. And that's because negative 6 plus 6 is 0. So it kind of cancels out. Then we have 0 plus 6. And 0 plus 6 is 6. So we have 3x equals 6. We want to get x by itself. It's being times by 3. So we need to move that 3. And because it's being times, we do the opposite of timesing, which is dividing. So we divide both sides by 3. So 3x divided by 3 equals 6 divided by 3. Over here, 3x divided by 3, the 3's cancel. We're just left with x. Over here, we have 6 divided by 3, which is 2. So our x-intercept for this equation over here is 2. Now we're just going to do the same thing, the equation on the right. So we have 4y equals 3x plus 12. Again, to find our x-intercept, we make y equals 0. So replace this y here with a 0. And then we can just tie that up because 4 times 0 is the same thing as 0. So we have 0 equals 3x plus 12. We want to get 3x by itself, so we need to move this plus 12, being plussed. So we need to do the opposite of plussing, which is subtracting. And what we do to one side, we have to do both. So we subtract 12 from both sides. Over here, we have 0 minus 12, which is the same thing as negative 12. Over here, we have 12 minus 12, which cancels out. So we're just left with the 3x. Then we want to get x by itself. Right now, it's being times by 3. So we need to do the opposite of timesing, which is dividing. So we divide both sides by 3. So we have negative 12 divided by 3. And 3x divided by 3. So 3x divided by 3, the 3's cancel out. So just left with x. Then negative 12 divided by 3 is negative 4. And then I just like writing this with x on the left, just because I like to have my letters on the left. So we have x equals negative 4. So our x-intercept is negative 4. Now we have this information ready to graph. So this is just the information we found before. So for 3x minus 6 equals 5, we've got our y-intercept of negative 6, x-intercept of 2. And we see I've just marked it on here. So y-intercept of negative 6, x-intercept of 2, and then I've just drawn a line going through those 2 dots. That's the yellow line. Now for our other line, we have 4y equals 3x plus 12 with a y-intercept of 3 and an x-intercept of negative 4. So I've marked those on. So that's our y-intercept of 3 on our y-axis. Remembering y is to the sky, so y is this vertical axis here. And then our x-intercept is negative 4. And x is always our horizontal. So I've marked those both on, and then I've just drawn a line going through them. And we can see here that these 2 lines intersect. And this intersection is going to be our solution. So I've circled that point of intersection where the 2 lines overlap or cross each other. You can think of it different ways. But we can see that's what's happening here. So it kind of forms a sort of X. Okay, and we can see this intersection is happening when X equals 4 and Y equals 6. So it's coordinate 4, 6. And our answer is X equals 4, Y equals 6. Okay, here's another example. So we have 3x plus 4y equals 12. And y equals negative 2x minus 2. Same idea, we start by finding our y-intercepts. So y-intercepts occur when x equals 0. So replace the x with 0. which you see it's just happened here. And then we just tie that up a little bit. So 3 times 0 just means 0. So we can write that 0 plus 4y equals 12. Now, adding 0 to something doesn't do anything. So 0 plus 4y is the same thing as just 4y. So we have 4y equals 12. When you get y by itself, we need to move this 4. That's getting in the way of y being by itself. Right now, these are being times together. So we need to do the opposite of times, which is dividing. And what we did on one side, we have to do both. So we go divide by 4, divide by 4. Over here, 4y divided by 4, the 4's cancel out. So we're just left with y. Over here, 12 divided by 4 is 3. So we can see our y is 3, so our y-intercept is 3. Now we're going to do the same thing for this equation over here. So again, to find our y-intercept, we make x equals 0. So we just substitute that at x equals 0. So we have negative 2 times 0 minus 2. Now we tidy that up because negative 2 times 0 is the same thing as writing 0. Timesing anything by 0, you just get 0. So we have 0 minus 2. And 0 minus 2 is the same thing as negative 2. So we have our y-intercept is negative 2. Now we need to find our x-intercept. So to find our x-intercept, we make y equals 0. So we're going to replace the y here with a 0, as said. So we've got 3x plus 4 times 0, and times, so putting brackets both means the same thing, equals 12. Now we tie it up. So 4 times 0 is 0, because anything times by 0 is 0. Now we can tie that up. So 3x plus 0 is just 3x, because adding 0 to something doesn't change its value, stays the same. So we have 3x equals 12. We need to get x by itself. 3 is getting in the way of that, and they're being times together. So we do the opposite of timesing, which is dividing. What we do to one side, we have to do to both. So we go 3x divided by 3 equals 12 divided by 3. Then we tie it up. So over here, 3x divided by 3, the 3's cancel. So we're left with x. And over here, 12 divided by 3 is 4. So our x-intercept is 4. Now you do the same thing for this equation over here on the right. So again, to find our x-intercept, we make y equals 0. So we replace the y here with a 0. So we have 0 equals negative 2x minus 2. We want to get this negative 2x by itself to start. So we need to move this minus 2 being subtracted. And we can just write without the 0, that's fine. So it's being subtracted. So we need to do the opposite of subtracting, which is adding. So we add 2 to both sides. So we have 0 plus 2 equals negative 2x minus 2 plus 2. Over here, we have 0 plus 2, it just becomes 2. Over here, the 2's cancel out because negative 2 plus 2 is 0. And we know 0 doesn't affect anything, so we don't have to write the 0. Okay, and now we want to get x by itself here. See what's getting in the way of x being by itself is this negative 2 being times together. So we need to do the opposite of times, which is dividing. So we divide both sides by negative 2. And that's what's happened here. So we have 2 divided by negative 2 equals negative 2x divided by negative 2. And then we just go to here. So we have 2 divided by negative 2 is negative 1. And over here, the negative 2's cancel out, so just left with x. And then I just like to write this with the letter on the left-hand side, just because I like the look of it. So x equals negative 1. So our x-intercept is negative 1. Okay, and now up to graphing. So you can see here we've got our purple line. So it's got a y-intercept at 3, an x-intercept at 4. And we see again, that's our y-axis, that's at 3, x-axis, that's at 4. And then we just draw a line going through those 2 points. And to do that, you just put your ruler on the page and just make sure you're cutting through those 2 points. Okay, and then same deal for our yellow line. See, we found that our y-intercept was negative 2 and our x-intercept was negative 1. So I've marked those on with some dots and just drawn a line through them. And again, we can see we have an intersection, which means we're going to have a solution. If we don't have an intersection, then it can mean that we don't have a solution. So simultaneous equations. Okay, so our point of intersection is just circled, and we can see the coordinates of that point of intersection are negative 4 and 6, which means our answer is going to be x equals negative 4, which we just got from there, and y equals 6. Okay, last question here. This one's going to be a little bit different because we're not going to have both an x and y-intercept. We're going to see how that works. Okay, we're going to start off the same though. So to find our y-intercepts, we again make x equals 0. That's what we always do to find our y-intercept. And then we just substitute that in over here. So we replace the x here with a 0. So 0 plus 5 equals 2y. Just tie that up. We don't really need the brackets. Doesn't make much of a difference. So 0 plus 5 equals 2y. Adding 0 to something doesn't change its value, so we can just write that it's 5 equals 2y. Then we get y by itself. And right now the 2 is getting in the way of that. So we're going to divide both sides by 2. And we're dividing because 2 and y are being times together. We do the opposite of that, which is dividing. So we divide both sides by 2. So 5 divided by 2 and 2y divided by 2. 5 divided by 2 is 2.5. And then 2y divided by 2, the 2's cancel out. We're just left with y. So our y-intercept for that first one is 2.5. Okay, now another line over here. We got y equals 3x. So we start by substituting x equals 0. And that gives us y equals 3 times 0, which gives us y equals 0. Now, so our y-intercept is 0, that's true. And I've just got an important note here. And that's just when our y-intercept or our x-intercept is 0. And if either of them is 0, it means they're both 0. So if either of them is 0, then we're going to need a table of values just to draw our graph, because we're not going to have quite enough information. And we'll see what that looks like on the graph later. Okay, now we're going to find our x-intercepts like before. So to find our x-intercept, we make y equals 0. So it's the same deal. So we replace the y here with 0. 2 times 0, same thing as 0. Then we want to get x by itself. Right now we have this 5 in the way, and the 5 is being added to our x. We need to do the opposite of adding, which is subtracting. What we do to one side, we have to do both. So we minus 5 from both sides. Over here, they cancel out because 5 minus 5 is 0. So that just kind of goes away. Over here, we have 0 minus 5, which gives us minus 5. So our x-intercept for our first line is minus 5. Now to find our x-intercept for our other line, we're going to do the same thing. We're going to go y equals 3x. Then we're going to make y equals 0. Is what's happened here. And then we can write that without in the brackets. So 0 equals 3x. And we're going to get x by itself. We need to move this 3. This 3 and x are currently being times together. So we need to do the opposite of times, which is dividing. So we divide both sides by 3, as we can see here. Now 0 divided by 3 gives us 0. 3x divided by 3, the 3's cancel, just like with x. That's telling us our x-intercept is 0. Now again, we have that note that when either our y or x-intercept is 0, we're going to need a table of values, just to draw a straight line graph. Okay, and this is that table of values just here. And again, this note, and the reason for this is because we only have one coordinate. And one coordinate, we have a lot of different lines that we could draw. And I might just draw what I mean by that really quickly on here. So there's our axes. If this is the only coordinate we have, this is one line that works for that. I just change colors. Here's another line that works for that. We have a lot of different lines that work for that one coordinate. Whereas when we have two coordinates, like something like this, we have a clear line, so we want to be drawing. Okay, and I just clear that. So what we do instead is we just have this table of values. And that's just what's happening here. So if I tell you values for y equals 3x, so I've gone for x values between -2 and 2, I just filled that in. And then we're going to find the y values to go with it. So for this value here, we're going to go 3 times -2, where we're just replacing the x value with what's here. So 3 times -2 gives us -6. Now for this one here, we're going 3 times -1, where we're just replacing this x value here with the x value in here. So 3 times -1 gives us -3. That goes in here. Then for this box here, we're going 3 times 0. Because the 0 is just from here. Just replace the x with 0. And 3 times 0 is just 0. For this box here, we're going 3 times 1. We're going 3 times 1 with the x value coming from here. 3 times 1 is 3, so that just goes in there. And then for this value here, we're going 3 times 2. We're just replacing the x value with 2. So 3 times 2 is 6. That goes in that last box there. Okay, and that's our table of values. This table of values just tells us that our straight line, y equals 3x, crosses through the points -2, -6, getting that from there, -1, -3, 0, 0, just from here, 1, 3, and 2, 6. So now we have lots of coordinates, and we knew we needed at least 2. Because before we only had 1, which was 0, 0, which wasn't quite enough information. Okay, so you can see we've got a graph. The yellow lines like the ones we graphed before, where we've just marked on 2.5 is the y-intercept, -5 is the x-intercept, and just drawn lines straight through those. For our table of values, we've had those 6 points. So we've got the -2, -6, -1, -3, 0, 0, 1, 3, and 2, 6. So I've marked them all on with dots and drawn lines just cutting through all those values. And you can always use the table of values, that's what you prefer, rather than finding x and y-intercept. That's always another option. Okay, and now we have both these lines here. We can also see they have a point of intersection, which we go through and circle here. And that's a little bit off. We can see the point of intersection here is at 1, 3. So we have x equals 1 and y equals 3.